We have discussed forces, moments, principle of moments, and ways to find the moment of a force, etc. in the last couple of videos. And in this video, we are going to see supports and support reactions. So, as you can see here, you have a beam shown here with two supports. These kind of supports are called simple support or a knife edge support. These kind of supports can provide vertically upward reactions or the reactions that are normal to the surface. Apparently, this will not be able to provide any or resist any sliding motion or resist any moment. So if there is a force acting in the horizontal direction, these kind of supports will not be able to resist it. But a vertically downward force will be resisted by these kind of supports. The roller support is almost same as that of the simple support. These also can only provide vertically upward reactions, which means it can only resist the forces acting vertically downward or normal to the surface. The reaction will always be normal to the surface shown here. And again, it cannot resist any sliding motion or any moments. So if there is a horizontal force, there will not be any reactions against that force. So these reactions will always be normal to the surface on which the rollers these rollers are placed. What is shown here is a pin joint or a hinged support. As you can see here, this is a support which almost resists the motion of or movement of this beam away from this hinged support. But it cannot resist any moment, which means the beam is free to rotate about this point. But if there is a horizontal or a vertical force acting on this support, it will be resisted. So the reaction on this support is depending upon the type of loading. If it's a vertical load, then the reaction will be vertical, and if it's an inclined force acting on this member, then the reaction also will be inclined. So the kind of reaction produced at this support will be depending on the kind of loading. But as I said before, it cannot resist a moment, so the body will be free to rotate about this point. And next is the smooth surface support. As you can see here, the two bodies are resting on smooth surfaces. The reaction provided by the surface will always be normal to the surface. So if the surface is inclined, the reaction also will be inclined, but the reactions will always be normal or perpendicular to the smooth surface. The body is free to rotate, so there is no horizontal or no friction acted on the smooth surface. A smooth surface means there is no friction. So if you allow the body to rotate freely, then that will keep on rolling because there is no frictional resistance offered by the surface. The reactions provided by a smooth surface will always be perpendicular or normal to the surface. There are quite a lot of problems or quite a lot of practical applications of these kind of supports in engineering mechanics. We will see those in the next videos. This is a fixed or built-in support. As you can see here, this kind of support resists almost all kind of motions or provides reactions in almost all directions. And also this can resist a couple or a moment. So a counterclockwise or a clockwise moment will be resisted here, and vertical upward or downward motions or for that matter, it can also resist a horizontal force as well. So fixed or built-in supports can provide reactions in both directions, vertically, both directions, horizontally, and also it can resist a moment. So it will keep the body fixed irrespective of the type of loading. So it can provide x and y directions reactions, and also counterclockwise and clockwise moments as well. So in the next videos, we will see how to create bending moment and shear force diagram. So now that we have discussed the forces, moments, and the ways to find the moment of a force, and also the different kinds of supports in these videos. So from next video onwards, we will see how to create the diagrams of bending moment and shear force, and also we will see different kind of loading, uniformly distributed load or uniformly varying load, or a load at a point and such like. We will see those things from the next video onwards.